Welcome to our channel Programming with Praveen Khanna. Today's our C language topic is on algorithm. Algorithm is a set of instructions in a simple language. Here you see here algorithm is a step-by-step procedure to solve a problem. It's a step-by-step procedure. Next it is English like statements. Algorithm will be in the form of English like statements. Each statement should be clear, simple, well-defined and set of finite instructions. Here you see here characteristics of an algorithm. Every algorithm will have input. You see here this is the algorithm of addition of two numbers. Here you see step 1 start. Every algorithm will begin. Step 2 read A and B. This algorithm for addition of two numbers. Here we are reading A and B, two values we read. After that sum of these two numbers will be assigned to the sum. Next we have to print that sum. After that we have to enter the algorithm. This is the algorithm. Algorithm is used for solution for a particular problem. It's a step-by-step instructions. It will be in a simple language, simple, clear, well-defined and finite instructions. It should be a few instructions. You see here characteristics of an algorithm. Every algorithm will take 0 or more inputs. For example, if I want to display hello program, in that there will be no input, only 0 input. Either we have 0 input or more inputs. Next, every algorithm will have output. It produces output. Next, definiteness. Each instruction should be clear. All these are the characteristics: input, output, definiteness, effectiveness, finiteness. 5 characteristics of the algorithm. Input, it takes 0 or more inputs. Output, it produces output. Definiteness, each instruction should be clear. Effectiveness, instructions should be effective. That means simple. Next, finiteness. It should be sequence of finite instructions. Every algorithm has to be ended with a few lines, finite lines. So, finiteness, it should be sequence of finite instructions. Algorithm is a sequence of instructions in a simple language. Okay. Next, it will be in the form of English like statements. Next, algorithm notations. Notation means numbers. You see here, these are the algorithm notations. Name of the algorithm. You see here, this is the name of the algorithm. Addition of two numbers. Next, second notation is step number. Each step should be indicated with a number. You see here, each step is indicated with a number. Step 1, step 2, step 3, step 4, step 5. Next, explanatory comments. Mention in square brackets. For this, for each instruction, for explanation purpose, we can write in left and right square brackets. You see here, read A and B. Why we are using this instruction? For reading the values. So that explanatory comments should be enclosed in between left and right square brackets. Next, termination. Every algorithm will stop. Every algorithm will end. Here it will begin and it will end. In between begin and end, in between start and stop, we write the instructions in a simple language. This is the termination. End of the algorithm. This is the end of the algorithm stop or a last instruction. This is the algorithm. Before we write any program, first we have to write the algorithm. After that, after algorithm, we write flowchart. Flowchart is a pictorial representation. After the pictorial representation, flowchart, we write pseudocode. Based on the algorithm, we develop the pseudocode. Pseudocode is the logic of the program. After that, we develop the program. We write the program or code. Flowchart. Flowchart is a pictorial or diagrammatical representation of the algorithm. At the beginning, we write the algorithm. After that, we write the flowchart. Flowchart is the pictorial representation or diagrammatic representation of the algorithm. Here, this is the flowchart. This is the flowchart for sum of two numbers. Okay, this is the flow of logic. This is the sequence structure. Okay, flowchart is the flow of logic. Here, why we use the flowchart? For easy understanding and for easy analyze the problem. For easy understanding and analyze the problem, we use the flowchart. We can easily understand the particular problem. Here, flowchart is used to solve a problem. For that purpose, we draw the flowchart. Next, here it is flowchart will be constructed by the symbols. Each symbol is used for a particular operation. You see here, this is the symbol, this is the use. You see here, this symbol is for start or stop. Okay. You see here, this parallelogram is for input and output operations. Input output statements we write in this parallelogram. The circle is used for connector or continuation part. If I want to continue my flowchart in another page, at the end of that, I will use this connector. This represents continuation on the next page. Next, this is the operation or assignment. For example, C is equal to A plus B. Like that, assignment operations will be written in this rectangle. Next, this is the decision making. This is for this up arrow, down arrow, right side arrow, left side arrow is used for connection or flow. You see here, flow is going like this arrow, sequence structure. Next, here, this is the module call or function like printf and scanf. For that functions, we use this for module call or function. This rectangle, dotted rectangle is for compound statements. We write the compound statements in this dotted rectangle. Next, you see here, flowchart for sum of two numbers. You see here, start. Flowchart will begin with start. After that, in parallelogram, we write read A and B. Next, this is the sequence structure. In the flow will be there in sequence order. Sum is A plus B. After that, write sum. What we got, the addition of two numbers that is there in the sum. We assign the result into sum. Then we display. For that purpose, we write sum. After that, we end stop. So every flowchart will end with the stop. Every flowchart will begin with start. This is the flowchart. Here this is the representation of algorithm to solve a problem. Here it is used for logic of the programs. Next, why we use flowcharts? For easy understanding and analyze the problem. Here we use the symbols. To each symbol represents operation. This symbol for start or stop. This symbol for input or output statements. This circle is for connector or continuation. This rectangle for operation or assignment. This diamond symbol for decision making. These arrows for connection or flow. This rectangle is for module call or function. This dotted rectangle for compound statement. Okay. Next example for the flowchart is example for sum of two numbers. Start, read AB, sum is A plus B, write sum, stop. After displaying the output, we stop the flowchart. Thank you friends for watching this video. If you like it, please share and subscribe.